Hi and welcome. I'm trying to learn histology today, tissue repair, and after we've done with, we're going to do wrist training. And if you participate in wrist training, then it's at your own risk. Tissue repair, and this is no medical advice. Tissue repair is the process in which worn out, damaged, or dead cells are replaced. Okay, the human body, they can have worn out, or damaged, or dead cells. And now the process of repairing them is called tissue repair. New cells originate by cell division from either the stroma, the supporting connective tissue, or the parenchyma, cells that constitute the tissues or organs functioning parts that read vertical. So the new cells originate by cell division from either the stroma, that is the supporting connective tissue, or of the parenchyma. These are the cells that constitute the tissue or organs functioning part. I think I thought of what about it last time, and I think I tried to make it pretty clear that stroma is the structural part. So the supporting connective tissue, stroma is the structural part, and parenchyma is the functional part. Parenchyma cells that constitute the tissues or organs functioning part. Okay, now these new cells, they can originate either from the stroma part, which is the part giving the organ structure, or the parenchyma, which is the part which gives the organ the function, or which is doing the function. In adults, each of the four basic tissue types, epithelial, connective, muscle and nervous, let's use it again, epithelial, or connective, or muscle or nervous, has a different capacity for replenishing parenchymal cells lost by damaged disease or other processes. Okay, the four different parts, epithelial, muscle, nervous, and connective, they have different capacity to make these cells again new. Epithelial cells, which endure considerable wear and tear and even injury in some locations, have a continuous capacity for renewal. Epithelial, it mustn't be the one of the skin. We're talking about that. Okay, they have a continuous capacity for renewal. In some cases, immature and undifferentiated cells called stem cells divide to replace lost or damaged cells. Okay, I think we're talking of epithelial cells, whatever. There are these stem cells. They can divide and then replace damaged or lost cells. For example, the stem cells reside in protected locations in the epithelium of the skin and gastrointestinal tract to replenish. We're using that word again, what does it mean? Replenish cells slaughtered from the apical surface, and stem cells in red bone marrow continually provide new red and white blood cells and platelets. Let's read it again. For example, stem cells reside in protected locations in the epithelium of the skin. Okay, are these protected locations? Let's take them for a second by the word. There are protected places in the skin. They are protected, and in these places are these new prototypes of the new stem cells, whatever. Just the idea, are there sectors in the skin? And in different places are different things. Maybe we'll take them a little. For example, stem cells reside in protected locations in the epithelia of the skin and in the gastrointestinal tract to replenish cells slaughtered from the apical surface. And we have the apical surface when we were talking about the epicline glands. And they were an idea that human have them, but probably don't human have them because the mammal glands are not these ones, they are neocline glands. These are the accumulate at the surface, what is it called? Whatever they're secreting out, they secrete product, and then they putting off, they're sending it off, that part. Now, from all that, it is pretty clear that we're talking about, I don't know what I wanted to say. Whatever, then the gastrointestinal tract, there are the places where these cells can be replenished from if they were slaughtered from the apical surface, and there are also stem cells in red bone marrow. Where is red bone marrow? And stem cells in red bone marrow. Maybe already wrong. Continually provide new red and white blood cells and platelets. Okay, out of the bone marrow, the red bone marrow, whatever the bone marrow that is inside the bone, there is coming out red and white blood cells and blood pellets. In other cases, mature differentiated cells can undergo cell division. Examples are hepatocytes, these are liver cells. The hepatocytes. The hepatocytes, these liver cells, are endothelial cells and blood vessels. Do we explain it? Some connected, no, we don't. Whatever, there are some who can do cell division, and there are these hepatocytes, they are in the liver, and they are, whatever, they are endothelial cells. No, they are also endothelial cells and blood vessels. There are the hepatocytes and liver cells, and the endothelial cells and blood vessels, and they can undergo separation. This is called division, if they are old enough. Whatever. Some connective tissues also have a continuous capacity. Some connective tissues also have a continuous capacity for renewal. One example is bone, which has an ample blood supply. What does ample mean? Whatever. Bone has an ample blood supply. And that means that helps bone, I can't find the line, bone, which helps bones to have a continuous capacity for renewal. Other connective tissues, such as cartilage or fibrous connective tissue, can replenish cells less readily, in part because of a smaller blood supply. That is very interesting. Is that the reason why carpal damages heal slower? Or do they? I don't know. I don't want to claim it. Do they? Or is it another reason that they're so problematic? Muscle tissue has a relatively poor capacity for renewal of lost cells over time. And this is anyway the new line back. That means we're done with reading of histology. If you were here for histology and reading about tissue, whatever it was, tissue repair, you can go to the next part of histology where we will continue with the tissue repair, reading about it. If you stay and participate in whatever that is, the Wristtraining, then it's better the hours. So if you stay and participate, then it's better the hours. Go to stable stance, and we're going up next to us, hands on the wrists, and we're bringing these wrists down and again up, and that is the spotlight. Now we go on with the next exercise with flashlight fists and under the inside and under the outside. Now, and we're having 3 rules. The first rule is that we're stopping immediately as soon as there's pain. And the next exercise, what the second rule? Next exercise, we're having flat hands and under the inside. The magician. The second rule is that we're going on as fast as we can go with a little bit of it. And the third rule is that we're not overdoing it. We just understand that we're not doing exercise. And the next exercise is pancake flipper. Flat hands. Oh. Next exercise for the T-Rex in the morning. Flat hands out and bring them down. Down. And we go on with the next exercise. Fists out with the quadrangular castle to the inside. And up. To the outside. Down. And change down. Outside. Up. You can skip the next exercise, we have quite a lot left. Clap anxious with fever. Down next to us, hands front to fist. Bring the hand down and press it with the inside. Pull it from the outside. Press it from the top. And on the other side. With the hand, bring it down and press it with the inside. Pull it from the outside. Press it from the top. And And the next exercise, let's go on with the T-Rex hinge. If you're doing it without a tennis ball, just make a strong fist. Release. If you're doing it with a tennis ball, then press with moderate force into the tennis ball. And release. And last time. And we're switching. Press again. Release. And press. Release. And press. And the next exercise. Cautious big bang. Putting the fingertips of one hand on top of the fingernails of the other hand, press it and up slowly. And switch. Relax exercise. So viele diese sind für straight fists and open. Close again. Last time. Now the bicycle bridge, flat hands and bend the middle knuckles. Up again. And another one. And the next exercise, you can skip it if you like. It is a frog testing the water temperature. Hands next to us, bring them down into flexion. Again, up strong fist. And down flexion. Up strong fist. Down flexion. Up. And that was the last time. Now we're doing the next exercise. Claw. Flat hands and bend them with the knuckles. And bending the knuckles. Next exercise. Arms in, strong fists into flexion, and out extension flat fingers. In strong fist flexion. Out extension flat fingers. And in strong fist flexion. And for the last round now. And the next exercise, the ice X. Flat hand, bend it at the knuckles, and press one of our fingers. And down. Other hand, and press one of our fingers. And already the last exercise, the unfolding rocket boosters. Good stance, long arms, strong fists. And bring the strong fists into flexion. Now the hands again to the outside, extension, flat fingers. The inside strong fist flexion. Outside extension, flat fingers. Inside strong fist flexion. And outside extension, flat fingers. Last round. And now we're going moderate force over the middle part of the arm. And on the other side. That was Wristtraining. I thank you very much, and the next time.